Hello, so I'm continuing processing of the astrophoto image of IC 1396, the Elephant Trunk Nebula, and wanted to record a note of this current step, which is narrowband normalization of the image. Just wanted to put the caveat, the disclaimer right away that this is in no way a tutorial for astrophoto processing. There are excellent resources online on various workflows for processing by people who are much more knowledgeable than I am. There are also more organized kind of series of explanations of various algorithms involved. I'm in particularly following Adam Block. He has a series of courses that are very useful for image processing in general, for any kind of scientific visualization, in addition to astrophoto, although that was the primary intent, I think, of the resources that were put out there. So in contrast, when I'm working on either scientific projects or artistic images, models, things like that, I often find that once the final product is done, so the image is produced, the model is built, the intermediate steps are kind of lost. They are covered by the subsequent steps. And first of all, it's useful to keep track of them for future reference. And second, I find that they are kind of fascinating in their own right. So I wanted to keep this as kind of a lab journal or studio log to document these steps. So perhaps you will find them useful as well. So this particular step is called narrowband normalization, and this is related to balancing out the color channels in the image that's composed of the data consisting of hydrogen alpha, oxygen 3, and sulfur 2 emissions from a deep sky object like the elephant trunk, for example. When we use fluorescence, gas fluorescence in scientific research, we acquire images using a monochrome camera, and typically if we are after numerical information, so for example some kind of scalar measurements of the flow that are related to the levels of emission, then we just work with those images. We don't combine them into a color one. But combination into a color image is great in terms of presenting 3 data sets in one. So in terms of communicating a large amount of information, it's quite powerful, also artistically pleasing. And there are some conventions, particularly in astrophotography, in kind of artistic astrophotography. There are standard color palettes that people recognize and can interpret. So specifically, I'm using the SHO palette here, where sulfur is mapped to red, hydrogen to green, and oxygen to blue. And the initial images, the levels of recorded light intensity corresponding to these emissions are very different. Hydrogen alpha dominates. And when the image is combined, it's good to balance the relative intensity of the images for more pleasing visual representation, which is also useful for discerning the spatial structure of the object. And one note I wanted to make, that in order for the narrowband normalization to work, the mean levels of the red, green, and blue, or the sulfur, hydrogen, oxygen channels, they need to be approximately equal. So this can be done in various ways. Can be just used automatic screen transfer function type stretch, and then making that stretch permanent, and then normalizing the combined image. But the more appropriate, arguably, way is to first, on the linear images, before they've been stretched, to apply the LinearFit to the 3 channels, using the hydrogen alpha as the reference image, as the brightest one. The LinearFit adjusts the background intensity, so kind of the black intensity levels to match that of the hydrogen. That is important because in the linear state we apply several other image corrections. It could be a gradient correction for light pollution, things like that. But importantly, deconvolution, which sharpens the image by removing, recovering the loss of details that was blurred due to light passing through atmosphere and the telescope optics. That process is benefiting from the LinearFit applied first. And then after that is done, the combination of the channels is performed and the narrowband normalization can be done. So that certainly changes the visual state, the impression of the image compared to a non-normalized one. And after that, the contrast of the details and the color intensity, etc., can be further enhanced in subsequent steps.